recording. So the main issue with subtraction is normally you cannot create a calculator that will do subtraction separately from addition. Why is that? Because it resolves to a complicated circuit. Because incidentally, no, it's a known solution that addition can be used for subtraction just by converting the subtrahend. Remember, the subtrahend in a subtraction is the negative number. By converting the subtrahend into a certain form called 2's complement, okay, such that when you add them together, the effect will just be like subtracting them. Okay, do you follow? So we will introduce a new representation, a representation of negative numbers, both for fixed point and by the way, whole numbers, not integers. Okay, any questions so far? So in case of binary addition, when you add 1 to 1, 1 plus 1 is 0, carry 1. You carry forward to the next order bit. In binary subtraction, 1 minus 0 is easy, no? 1 minus 0 is 0. But when you say 0 minus 1, that's a problem because we cannot subtract 1 from 0 because it's greater than 0. So what we do is we borrow from the next order bit, the next bit to the left, and get the remainder as 1. So for example, we say 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0. But when you say 1 minus 0 minus 1 equals 1, why is that? Because when we borrow 1, the 1 we borrowed is a 2, right? It's actually a 2. Like in binary, the 1 we borrowed is actually a 10. This time it's a 2 because it's a next higher bit. So 2 minus 1 is a 1. Do you follow? So that's why 0 minus 1 is a 1, borrow 1. Okay? Any questions so far? No? So simple, no? It's just like binary numbers. You just borrow, but this time you borrow 2, not borrow 10. Okay? Here's an example of a binary subtraction in subtraction in binary. You say, for example, we have 123.75 minus 85.5. Okay, 123.75 is, this is the representation of 103.75. No, you can convert this yourself, but the 0.75 is accurate because the first one is a 0.5, the second one is a 0.25. So this is a 0.75. Now the subtrahend 1 0 means 1/2. Okay, so it's a 0.5. No? So how do you subtract this? Okay, you say 1 minus 0 is 1, right? 1 minus 1, that's 0. 1 minus 1 is 0. 1 minus 0 is 1. Now, 0 minus 1 cannot be, so we borrow 1. But this one is actually a 2. So 2 minus 1 is a 1. And this became a 0 now. So 0 minus 0 is a 0. You follow? So that's the example. Then 1 minus 1 is a 0. 1 minus 0 is a 1. 1 minus 1 is a 0. You follow?
Sir, may question ako, sir.
Yes.
Bakit naging 2 yung 0 yung nag-borrow siya sa left niya na bit?
Remember in binary, if you will borrow to the next bit, in decimal, di ba? When we borrow 1 from the next, the one we borrowed is actually a 10, right? Di ba, in decimal?
Yes, sir.
Now in binary, the one we borrowed here is actually a 2 because it's a next order bit. Di ba? But
Yeah.
this is a 2 because this is the next order bit. So we'll take this as a 2 minus 1, okay?
Yes, sir.
Because
Okay.
what we borrowed is actually a 2. So 2 minus 1 is a 1, and then borrow 1. So this becomes a 0. Diba? So it's a little tricky, but it's very similar to the decimal subtraction that we are used to. Diba? Okay? Because the previous one that we borrowed in decimal is a 10. The next one that we borrowed. So in binary, the next one that we borrowed is not a 1, it's a 2. Okay? So we'll treat it as 2 minus 1 equals 1. Okay? Do you follow? So 0 minus 1, in short, 0 minus 1 is a 1, borrow 1 from the next. Okay? So this became now a 0. So if you translate this, this is 38.5 because 0.01 is 1/4, right? And then this is a 2, 4, 8, 16, 32. So 32 plus 6 is 38. So this is 38.25. That's the same thing that you get if you do this by decimal. You
Ay,
follow?
sir, may isa pa lang question, sir ba?
Yes.
What if yung nasa left niya na bit na i-borrow niya is like a 0 instead of a 1? Ano mangyari?
You borrow from the next. So the next that you borrow is a 4.
Okay. Tapos if mag-next na naman 8 na naman yung
Pag
kunin.
next 8 na naman. Okay? Just like in binary, in decimal, if the previous one that you borrowed is a 0, you borrow to the next, it becomes a 100. So what you have here will be a 10, and this will become a 9, a 9, right? The
Pero
0
ano
becomes,
mangyari, sir, if like, di ba nakaborrow daw siya ng 8 sa kabila, no? Tapos maging
oh,
8 minus 1, anong mangyari?
iyan ang problema ngayon. That's a problem when you are doing negative numbers, especially if the subtract is bigger. That's also one of the main issues. So anyway, when we do 2's complement representation, that will not be a problem because we will not do subtraction, we will do addition. Do you follow? Actually, that's also one of the issues when you subtract a bigger number. Do you follow, no? So actually, it can be done, but that's not the practice. We do not do subtraction by binary subtraction. Do you follow? We will not do binary subtraction. We will only do addition. Okay. So the same thing actually happens, no? To make a long story short, the same thing happens in decimal. It's just a longer story, but the simpler approach is to use addition. Okay. Okay. We'll just proceed. Anyway, we'll not do this again. Okay. We'll do subtraction by addition. Okay. And it will be a robust process. It's a perfect process, even if you have bigger subtrahends. No? Anyway, let me proceed. No, so that I can give you the now to explain the whole process of subtraction by addition. We have to understand some properties of binary numbers. Okay, binary numbers. No, binary numbers come in pairs. No, they're like male and female, husbands and wives, you know, boyfriends and girlfriends. No, they're actually a pair. No, if you have an n-bit number, okay, the following properties apply. The maximum value of an n-bit number is 2 to the n minus 1. For example, if n is 4, okay, the maximum value is 2 to the 4 minus 1. 2 to the 4 is 16 minus 1. The maximum value is 15. So 1, 1, 1, 1. 1, 2, 4, 8. You add them together, that's 15. You follow? So, sir, you only get to borrow if the minuend is 0. You cannot borrow if the minuend is 0. You borrow from the next because there's nothing to borrow. The subtrahend is somewhere in the lower, okay? Ang subtrahend natin yung negative, okay? Minuend yung bigger. I hope, no? You cannot borrow from a 0, so you have to borrow from the next. There's a question by some genius, no? Isang beses lang po ba pwede mag-borrow? You can borrow from the next again. Okay? Until you get to borrow. Until the next is not a 0. Okay? So anyway, let's proceed with this, no? Basta wala na tayong problema sa borrowing if you do 2's complement, okay? The problem on borrowing will not be a problem, okay? So the maximum is 2 to the n minus 1, 15. Now, if you have this, the value of the most significant bit is 2 raised to the quantity n minus 1. So if you have 4 bits, 2 to the 3, 3 is 4 minus 1, is 8. So the most significant bit is 8. That's important to take note if you have an n-bit binary number. Any questions so far? No. So don't worry about the borrowing, okay? We will not use that anyway because computer circuits do not use subtraction, okay? Walang subtraction sa electronics. In fact, we will discuss that in the next chunk, when we discuss arithmetic logic units. Okay. Given two n-bit binary numbers x and y, one's complement. Okay. X is the one's complement of y if, and vice versa, if x plus y is equal to the maximum number of the nth power, 2 to the n minus 1. Remember, 2 to the n minus 1 is the maximum value for given n bits. For example, the number 10. No? What is the number 10? 1010. Okay. So this is how much is n here? 4, because there are 4 bits, right? 4 bits. Okay. What is the ones complement? So 2 to the 4 is 16, minus 1 is 15. So the maximum value is 15, right? We subtract 10 from the maximum value. So 15 minus 10 is 5. So 5 is the pair, no? 5 is the ones complement of 10. Why? Because 10 plus 5 is equal to the maximum value given the n bits. Okay? What's the maximum value at 4 bits? 15. So 10 plus 5 is also 15. So therefore 10 and 5 are ones complement. You can also say 11 and 4 are ones complement, no? 6 and 9, 7 and 8. Okay? 7 and 8, what do you have? 6 and 9 again. You can have 5 and 10, no? 11 and 4, 12 and 3. Do you follow? They are ones complement. Okay? So what are the ones complement if n is 4? You will have 1 and 14, 2 and 13. Okay? 2 and 13, you have 3 and 11, 3 and 12, 3 and 12, no? 3 and 12, you have 4 and 11, you have 10 and 5, 9 and 6, you have 8 and 7, and then you have 6 and 9, okay, and then you have 10 and 5 again, and you have 9 and 4, okay? Ones complement. Now, one important property is, if you take note, no, if 10 is 1, 0, 1, 0, 5 is 0, 1, 0, 1. Incidentally, that's another property which we can use to convert the ones complement. Take note that 10 and 5 are just flips of zeros and ones. If you flip the 1 in 10 to 0, and the 0 to 1, and the 1 to 0, and the 0 to 1, you will get 5, which is the ones complement. Do you follow? Which means that another way for computing the ones complement is just to flip zeros to ones and ones to zeros. Do you follow? No? That's the ones complement. Actually, that's called complement because they equal to the same value. For example, what is the ones complement of 123? We know that the next power of 2 is 128, right? 1, 2, 4, 8, 16, 32, 64, 128. Okay? So the maximum value for 128 is 127 because that's minus 1. So 127 minus 4 minus 123 is 4. So therefore, this is the ones complement of 123. If you do a binary subtraction, this is 127, this is 123, this is 4. Look at the appearance of 123 and 4. They're just flips of zeros and ones. Okay? Flips lang sila. Okay? Zeros and 1. Tingnan mo yung ones complement, yung 123 and 4 are ones complement. They're just flips. Zeros and ones. Okay? Now, this also applies to binary fractions, right? What, for example, you are given that a fraction with n is equal to negative 3, 0.111, okay? So the value of n is equal to negative 3, by the way, negative 3, no, going to the left is 0.875, that's the maximum value, okay? For example, you are given a value called 0.625, what's the ones complement? So 0.625, you deduct it from 0.875, this becomes, I'm sorry, okay? 0.875 minus 0.625 is 0.25. Do you follow? Or 1/4. So if you look at 0.625 is 0.101 and 1/4 is 0.010. So it's also a flip of zeros and ones. No? So the property of the maximum value also applies because 0.625 plus 0.25 is 0.875, which is the maximum value at n is equal to negative 3. Okay, so which means that incidentally we can also use the property of ones complement in binary subtraction involving fractions. Okay, so we know the ones complement. The twos complement is the ones complement plus 1. Okay, I hope you have moved on to the borrow problem. We will disregard it for now because it's a complicated issue and it's not used anyway. No? I'm just introducing you to show you the difference between binary and decimal and subtraction. Okay, the twos complement. okay, of 1, 0, 1 is 0, 1, 0, 0 plus 1. That's 0, 1, 0, 1. Now, the good thing about 2's complement is if you apply it again, it goes back to the previous form. So for example, if you have 1, 0, and 1, 0, you reverse it. This becomes 1, 0, 1, 1 plus 1. This goes back to the original form. So converting to 2's complement and back again involves the same process. Okay, you do not use a reverse process. Use the same process. It goes back to its previous form. So what's the 2's complement? The 1's complement plus 1. Okay. So there's the table of decimal values, binary numbers, their 1's complement and their 2's complement. In case you want to memorize, okay, but you don't have to memorize. You can convert them by flipping zeros and ones. Okay. Now, let's convert. Okay. How do we convert a fractional value into 2's complement? We apply the same process, but this time we do it with the least, the one, no? The one you add is added to the least significant bit. This time, no? The trailing and leading zeros, the leading zeros here and the trailing zeros here are important. We do not erase them in 2's complement because they were once converted to zeros. For example, you want to find the 2's complement of 123.75. Okay, 123.75 is 111.011.11, right? The 1's complement of this is this, no? 0.0000. Where do we add the 1? The 1 is added to the least significant bit. No, hindi pwede dito, hindi pwede dito. It's not here, but the least significant bit. You add it there. Okay? Do you follow? That's important. You add the 1 to the least significant bit. So the 2's complement is 0.01. Do you follow? You will make a mistake when you're doing subtraction if you do not add it to the least significant bit. Okay? Any questions so far?
How do you may question ako regarding sa previous na slide.
Yes.
Diba, for example, i-add mo tong 1.01 sa second, no? So maging 1 plus 1. Ano mangyari niyan, sir? Mag-carry on siya sa
Ito
left.
magiging 1 plus 1. It becomes 0 plus 1.
Okay, diba maging 0 plus 1 man siya, sir? So maging 1 siya. Then maging 1 plus 1.
Hindi, 0 plus 0. Because remember,
Hindi, yung sa taas pa, sir ba? Ay, di ba ito counted sa taas?
No, hindi. Because this is the 1's complement. We add 1 to the 1's complement. This is the original value. Sa taas, no? Di ba? This is the original
okay.
value.
I-convert mo siya to 1's complement.
Yes.
Oh, okay.
So 1's complement tayo. Okay? Mag-add. Not in the 2's complement. So this is 0 plus 0. This is just copied because they're not added. Okay? We add 1 to the 1's complement. Okay? Anyway, so now, how do you convert a 2's complement back to an integer value? This only applies to integers, no? Not fractions. No? For example, we know that a number is in 2's complement. We want it converted to its original value. Is there a shortcut? Yes, there's a shortcut. No? If we look at the MSB, if the MSB is 1, we compute the binary sum with the MSB assigned a negative place value. For example, here, 101011, we are told, oh, this is a 2's complement form. What's the value? The MSB is 1. We do the normal process, except that the MSB is assigned a negative value, negative 16. We add them together. This is negative 5. Even if you convert this to 1's complement, okay, and then do the reverse process, it's still negative 5. Okay. For example, with 01111, we are told this is a 2's complement number. What's the actual value? Now, if the MSB is 0, we extend it one more bit and assign it a value 1. Dagdagan natin ng 1. We add a 1 here. And we compute the binary sum using a negative value at that position. So negative 32, ito 16. 8 plus 4 plus 2 plus 1, that's negative 17. I'll give you an example on this, okay? In fact, it's in the sample test. Okay, so now we are ready to solve a sample, the sample given by our idol in math, no? Sino ba ito? Simple snippets. They are very good in math, no? And in IT also. Most of my resources are from Indian sources, no? Especially in web page. Web page development, they're very good. They're always very good. No? JavaScript especially. Ang galing ng mga Indians. So anyway, we will use this example. We have 26 minus 25, 25 minus 26, 11.25 minus 6.5. Okay? Okay. Any questions so far? I will upload the example on our website. Okay, on our regular site. Okay. So let's have an empty Excel. Skip na tayo. Sorry about that. Mali na. I have 2 Excels. Choose another. Let me. First is 26 minus 25. 26 minus 25. I'll just enlarge this anyway. Okay. 26 minus 25. We need a binary table, no? This is just an integer. So, ang gamitin natin are just positive values, okay? So, no? You follow? I have this ready, no? Where's the 1? Kulang tayo ng 1. Okay. Okay, you follow? Dito natin ilagay yung ating sum. Okay? We need to represent 26. You know this already, right? This is pick and mark. So for 26, we will need a 16. Okay. Now we're left with 10. We will need an 8. Then we're left with 2. We need a 2. And then this is 0. Okay. We follow. So this is 26. 26 is 11010. Okay. And then we'll copy this to convert 25. Okay. Convert natin yung 25. 25. Okay. The main difference between 25 and 26 is at the last. So this is 25. Okay. Any questions so far? So we need to compute the ones complement of 25. Right? Ones complement of 25. So what will we do? We'll just flip this. This is a 0. This is a 0. This is a 1. This is a 1. This is a 0. Okay. Any questions so far? So ones complement pa ito, no? And then we add 1. And then this will be the 2's complement. The 2's complement of 25 because we will add 1. Remember, we will add 1 to the 1's complement. I'm giving a row so that we can have a row for the carry. Okay. 0 plus 1. 1. So this will be 1, 1, 0, 0. The trailing and the leading zeros are important. Okay. They're important. We do not miss them. I'm sorry. Because they were actually converted from ones. Okay. So this is 25. We will now add 26. You follow? To get the difference. It doesn't matter whether 25 is above or below the 26 because anyway, we're just doing addition. This is our 26. Diba? Addition lang tayo. We're just doing addition. We are not doing subtraction. Okay? So, what is 1 plus 0? 1. Okay? 1 plus 0 is 1. 1 plus 1? 0. Carry 1. 1 plus 1 plus 0, that's also a 0. Carry 1. 1 plus 0 plus 1, that's another 1. And that's another 0, by the way. Carry 1. 1 plus 0 plus 1 is a 0. The last carry is a 1. We will disregard this. If the last carry is a 1, it's an indicator that the result is positive. Do you follow? Disregard natin ito. Okay? Do you follow? So remember what's our place values here? There's 16. No? 16. And take note, it's already correct, no? 25 minus 26 is 0, 0, 0, 0, 1. So 25 minus 26 is 1. Do you follow? 26 minus 25 is 1. Did it matter whether we place 26 above the 25? No, because it's only addition. Okay, now let's do the reverse. 25 minus 26. Okay. Let me do that separately here. 25 minus 26. Wala na tayo, there's no more problem about borrowing here, no? Because you're doing addition. So, no problem with borrowing. Okay? So, we'll copy this. Ito na lang, no? 16. Kasi hanggang dyan lang naman ang ginagamit natin. Okay, and then we'll have equals this times that. We copy this. And then we'll have the sum here. This is the same formula using method 3. Okay. And then our value is 25. Okay. Follow, and then we will subtract. Okay. So for 25, we will need a 16. We're left with 9, we need an 8. Okay. We're left with 1, so this will be a 0, 0, 1. Okay. That's 25. Any questions? 25 yan. So now we will convert 26. Copy this. Put here. 26. The difference between 26 and 25 is this is 1, this is 0. Okay. So that's 26. Okay. Now 26 is our negative number. There's someone waiting. Nobody's waiting now. Okay. 26 is our negative number. We will convert this into 1's complement. What's the 1's complement of 26? We'll convert this to 0, 0, 1, 0, 1. Okay. We add 1. So that we will have a 1's complement. Okay. So leave a few rows. 1 plus 1. That's 0. Carry 1. 1 plus 0 is 1. We'll just copy this. So this is the 2's complement of. Pwede ba ganyan? Pwede na. This is the 2's complement of 26. So we add 25. Anyway, it doesn't matter. Hindi mag-matter because it's just addition. Okay. We add 25. No? 1 plus 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 is 1. The last here is a 0. So this is a negative. Okay. So this is a number in 2's complement form. Do you follow? This is negative because the last carry is a 0. Unlike in the previous one, in our example, no, the last carry is a 1. So it's positive. In here, our last carry is a 0. This is negative. Do you follow? Do you follow? Okay. How do we convert this into binary, into decimal? Remember, we'll just use the same. Okay, we'll just use the same places. No, this is the most significant bit. The most significant bit is a 1, so we will assign a negative value. So that, no? Okay, do you follow? Kasi 1, kung 0 yan, we just extend it to the ano, and then convert it to ano, convert it. We'll extend it and add a 1 to the next. Okay, this. We'll sum this. Okay, so that's -1. Do you follow? No? Will you excuse me a while now? Just have to check something outside. I'm sorry for the disturbance. Is there any question? Sorry for the disturbance. No? So -1. This is, yes.
Sir, bakit -16 yan, sir? Ay, naging -16.
Because that's how you convert 2's complement back. Okay, it's here.
Ay,
No?
so,
How to compute the value of a 2's complement number. Okay? Kasi kung hindi, another way is this, no? That's the short way. Why do we know that this is a 2's complement number? Because the last carry is a 0. Do you follow?
yes,
No?
sir.
This one, is this a 2's complement number? Ito? Is this a 2's complement number? No.
No, sir.
No, sir.
Why? Because the last carry is a 1. Do you follow? Do you follow? No. This is a shortcut. When we know that a number is in 2's complement form, and we know that the MSB is 1, to compute the value, we just do this. Okay? Because otherwise, it will be a longer process, di ba? Because to convert this to 1's complement again, how do we convert this into 1's complement? We'll convert to 0, di ba? Gawin natin 0. This is the 1's complement, right? Right? This is the 1's complement of the answer. No? And then we add 1. Okay? So when we add 1, this is a 0, 0, 0, 0, 1. 1, I'm sorry. No? So this is a -1. Why? Because we know that it's given to be a 2's complement number. So right, this is 1, right? 1 ito. So -1. But we don't have to go through this. Mahaba ito eh. Do you follow? We don't have to go through this. What we do is we just compute normally. Okay? And assign a negative place value to the most significant bit. Do you follow? Why did we assign this a -16? Because we know that this is a 2's complement number. If it's not a 2's complement number, we will not assign it negative. You get my point? Oh, you sum it. 16, -16 plus 8 is -8, right? Plus 4 is positive, is -4. Okay? Plus 2 is -3. Tama ba tayo? Kasi kung 16 minus plus 8 is 8. Right? -8. -8 plus 4 is -4. -4 minus plus 2 is -2. -2 plus 1 is -1. Right? Do you follow? Okay? Do you follow? So this is -1. This is to check, no? To check. Okay? The decimal value is -1. Okay? The decimal value here is -1. This is 1111, but this is in 2's complement, so the decimal value is -1. Okay? So how do we convert a 2's complement number to decimal? Ganito yan. Look at the MSB. If the MSB is 1, you assign it a negative place value. Do you follow? If the MSB is 0, you extend it one more bit and assign that bit a negative value. For example, in this case, the MSB is a 0, lagyan natin ng 1. We add a 1. But that in that case, it will be a negative 32. We'll have another example on this, no? On the exercise anyway, no? Okay. That's a shortcut. If you don't like the shortcut, you can do the longer process, no?
Sir, anong MSB, sir?
The most significant bit. Diba?
Ay, di ba sa 2, wait, pwede, di ba sa 2's complement man yun, sir?
Yes, the most significant bit is also on the left.
Eh, di ba, di na siya maging 2's complement if 1 yung nasa pinaka-left niya? Like yung sa first example?
Where's that? Where's first example ito? Ito ba ito?
Ay, yung nasa PowerPoint, sir.
Sa PowerPoint, okay? Ito.
Yeah, di ba yung nasa taas, sir, kay 11011?
Yes.
Di ba kapag 2's complement, kay dapat 0 yung nasa pinaka-left?
Not necessarily. Depending on the value. Anong pinaka-last? Yung 1 dito? Yung 0?
Hindi, yung nasa pinaka-left niyan, yung 1.
Left ito?
Yeah,
No, not
yes,
necessarily.
sir.
Not necessarily. The carry, you mean the carry? The last carry?
Hindi din. Kasi pagkaintindi ko, sir, kay malaman mo if like 2's complement siya if 0 yung nasa pinaka-left,
No.
yung
Not
most significant.
it's not that way. No.
Mm,
A number is in 2's complement if the last carry is a 1. Is a 0. If the last carry is a 0. Like in this case, no? Like in this example, no? In this example, okay? This number is in plain form, not in 2's complement. Okay? Hindi ito in 2's complement because the last carry is a 1. Okay? However, this is a 2's complement form number. Why is that? Because the last carry is a 0. This is different from floating point, okay? And because in floating point, we reserve the last to be an indicator for the sign, right? In floating point representation, the leftmost bit is a sign bit. This is not floating point, okay? Baligtad kasi sa floating point. Sa floating point, pag last bit is a 1, that's negative. Integers lang tayo dito, no? This is not floating point. Okay, please do not confuse it as the last. Kasi in the floating point representation, the leftmost bit is the sign bit. No? It does not apply for 2's complement, okay? Do you get my point? So the thing that we say 1 on the left bit as the sign bit only applies to floating point representation of numbers, not 2's complement. It's the other way around in 2's complement. If the last carry is a 0, it's in 2's complement. If it's the last carry is a 1, it's in the plain form. Okay, did I answer the question? Okay. Okay, you follow? Now we are not talking about 2's complement, or rather floating point here, no? So the sign bit is not used. So anyway, so this is a negative 1. So if you look at the video, no, it does the same. Yung video niya, no, ni simple snippets. Look at this video, okay? This does the same. This proves that our computation is correct. Okay, any questions? Can we proceed to the last example? 11.25 minus 6.5, okay? 11.25 minus 6.5. I will have more examples, no? Okay. Now we need a different, first we will compute 11.5, right? We will need a different, we will need different, a different table because we now have fractions, right? So what table do we need? Let me just copy the table, no? Kung 11 kasi, we only need 8 hanggang 8, no? Okay. And 25, we only need hanggang 1/4, okay? Let me copy this. Okay. We'll put here 11.25, okay? 11.25, and this will be our sum. So ano, hindi ito fixed point, a floating point, no? This is 2's complement and the sign bit is not used. Okay. So we pick and mark as the usual process. So we pick 8. So we can pick 4. We can pick 2. 1, okay. Now we can pick 1. And then we can pick 0.5. No, we can pick this and then, okay. So this is 11.25, okay. Now let's do this again for 6.5. I made a mistake here earlier, no? Kasi I did not use the least significant bit. Okay. Do you follow? Any questions so far? Okay. So we can have, this is a 0, right? Now we have to include the 0 because 11 here starts with 8. Okay. We cannot remove this 0. Do you follow? We cannot remove that 0. So we have a 4. We have a 2. Okay. We have a 0.5, so we'll have this. And then we have this. We also need this 0. Do you follow? We also need this 0. Okay. What's the 1's complement of 6.5? Okay. So kasali itong 0 na to, ha. It's included 0, 0, 1, 0, 1. You follow? And then we add 1 to the last. So dito, so 1. Okay. 1 plus 1. Ilagay natin dito ang ano, 0, 1. So this will be a 1. This is a 1. This is a 0, 0. Okay. You follow? This is the 2's complement of. Now, hindi mag-work dito yung ano, no? Yung quick conversion to decimal because it's fractional. So we add 11.25. 11.25 is this. Just add. Okay. We add. Addition lang, no? No subtraction. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 0. Carry 1. You follow? Now, pag 1 plus 1 plus 1, that's 1, carry 1, no? Pag 1 plus 1, that's 0, carry 1. Okay? You follow? 1 plus 1 plus 1 is 1, carry 1. 1 plus 0 plus 1 is 0, carry 1. So this is 0, carry 1. Okay? 1 plus 0 plus 0 is a 1. 1 plus 1 is a 0, carry 1. Do you follow? So this is a positive number. Do you follow? Do you follow? So since this is a positive number, we can just use the places. Right? Okay. And then we will multiply the no. Okay. Okay. And then we'll do a sum on this. So the equivalent is 4.75. Do you follow? So 11.5 minus 6.5 is positive 4.75. Okay? Do you
Ay,
like that?
sir.
Yes.
Ano yung gawa mo dyan, sir? Hanap mga ones ng result nito?
This is our answer, right? Ito yung answer natin. Diba? Ito yung answer. This
Yes,
is the
sir.
final answer.
Ay, yung nasa pinaka-left, sir, na 1, din na yun siya count.
Hindi ito kasali. The last carry is not used. Always discard the last carry.
Ay, pang-indicate lang yan kung positive siya or negative.
O positive or negative yung result. This just indicate
Oh.
the result whether is in 2's complement or not.
Mm.
So we know that the result is positive because the last carry is a 1. So since we know that it's positive, we can now compute the actual value to decimal, and it's 4.75. Okay. Okay. So let's rename this. This is what's this? 26 minus 25. And this is 25 minus 26. And this is 11.25 minus 6.5. Okay. You follow? So if you do it in decimal, that's still 4.75. This time we are doing, and take note that since we are doing addition, there will be no problem about the borrow. Diba? Carry lang tayo dito. Forward carry. So carry is easy. So do you get my point now? That's why I brushed aside your question regarding the borrow, because in a way we will not use borrowing. Okay. There is no borrowing in addition. Do you follow? Do you get my point? Do you like us to do the reverse, or you do the reverse? Okay. We'll compute the reverse. Nandito lang tayo. 6.5 minus what? 11.25. We do that. 6.5 minus 11.25. Okay. We'll just paste this anyway, no? Baliktad lang naman sila. Okay. So we'll cut this. Ba ito yung 6.5. We will insert the axis. Okay, you follow. This is 6.5. This is now 6.5 minus 11.25. Do you follow? Do you get my point? Any questions so far? So negative ngayon yung 11.25. So now we will convert the ones complement. Okay. You follow? So what's the ones complement of 11.25? This is a 0. This is a 1. This is a 0, 0, 1, 0. Okay. Should be careful here, no? Tama ba? This is a 0. This is a 1. This is 0, 0, 1, 0. Okay. And then we add 1. 0 plus 1 is we'll allocate space. No? This is a 1. This is a 0, 0. This is a 1. This is a 0. Okay. We do not erase this 0. Okay. We do not erase this 0. Okay. Now we'll add 6.5. Okay. What's the 6.5 value? Is this? Okay. 1 plus 0 is 1. 1 plus 1 is a 0 carry 1. 1 plus 0 is a 1. 0 plus 1 is a 1. 1 plus 0, 1 plus 1 is a 0 carry 1. I think now we need the last carry, which is a last carry here. The last carry is a 1, which means that this is a negative number. Do you follow? Kasi wala naman, ito hindi na sila kasali. Although hindi na sila kasali because incidentally 6.5 is the, no? Okay? Okay? Do you follow? Do you get my point? So this is, I'm sorry, no? Mali, kasi dapat positive pala. I'm sorry, no? I think we still need to continue. So 1 pa pala dito, no? Kasi this should be a negative value. So I'm sorry, no? That's correct. That's 1, and the last carry is a 0, okay? So this is negative. Do you follow? Do you follow? Do you follow? Negative, no? Kasali yun. I'm sorry about that, no? Kasali talaga yun. This is insignificant because these were converted values. Okay? What is this value? Since this is a negative value, we'll just convert this into 1's complement. This will be 0. This because it's fractional, no? Hindi pwede yung shortcut. Because it only applies, the shortcut only applies to whole numbers. Okay? And then we will assign the place values. This should be a negative 4.5, no? Okay. Is it clear now that it's a negative 4.5? Yes, I think so, because this is a 4, no? This is a 4 and this is a 4.5. Okay? Do you follow? Even if you don't compute, it's 4.5. Can we sum this? Okay, we sum this. So this is 4.5. Tama ba tayo? 4.25 ba? Bakit mali? 4.75. Mali tayo, no? It should be a 4.75, no? Not 4.25. 4.5. Let's correct that again. Equals 11.25 minus 6.5. 11.25. 4.75. Let me check, no? Let me check this. Why it's 4.5? Baka mali ang ating ano. 6.5. This is 6.5. 6.5. That's correct. And then 11.25. This is correct. 1, 2. This is 11.25. And then, yeah, we convert this. This is 0. This is 1. This is 0. 0. This is a 1. This is a 0. We add 1. This is a 1, 1. Okay. 0, 0, 0, 1, 0. Okay. This is our 6.5. This is correct. Let us review this. 1 plus 0 is 1. 1 plus 1 is 0. Carry 1. Mali na ito dapat kasi 0.75 eh. Okay. Anyway, let's find out, no? 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0, carry 1. 1 plus 0 is 1, carry 0. Okay. This is negative, no? Okay. This is a negative form. No, mali pa tayo, no? Mali pa tayo, okay? Kasi dapat pa tayong mag-add ng 1. Okay, that's where we are wrong, okay? I'm sorry about that, no? Because this one's complement, okay, we need to add 1. Okay, that's where I was wrong, no? Hindi tayo nag-add 1. We need to add 1, okay? Do you follow? I'm sorry, no? So sometimes we're lost, no? 0 plus 1 is 1. 1 plus this 1, this is a 0, 0, 1, 0. Okay? This is a negative number. We add 1. Now, we have this is now that we convert into into decimal, okay? Do you follow? Kailangan pa natin mag-add 1. That's precisely why it was wrong. So, ito, klaro na ito, 0.475 kasi 0.5 plus 0.25 plus 75 na yan, di ba? Do you follow? Do you get my point? I'm sorry about that, no? But I will upload this, no? Okay, and then I'll sum this. Okay, so the correct answer is 4.75. Where was I wrong? Hindi ako nag-add 1, no? Always remember, add 1, okay? Always remember, add 1, okay? So this is now 4.75. Any questions? I will upload this. No, I will save this. And then ano ba ito? We'll use, okay. Online classes. This is 2020. This is yes, this binary subtraction simple. Okay, I will upload this to our regular site. Okay. Anyway, before I do that, let me check. We still have time now. I'd like to show you more examples. Actually, this is already part of the sample exercise. Sample exercise. Okay. Binary subtraction. Sample questions. Yes. Okay. Okay. Convert 83 to 1's complement. Okay. Any questions? Any questions? 83 to 1's complement. Okay, so 1, 2, 4, 8. Okay. Bakit ito? 1, 2. 1, 2, 4, 8, 16, 32, 64. Now, what's one way to convert one's complement? The next power of 2 from 83 is 128, right? Right? 128. Okay. So the maximum number at 128 is 127. Do you follow? So the one's complement of 83 is 127 minus 83 is 44. Okay. If you take a look at that at the binary table, it's 32 plus 8 plus 4 plus 4. Now 32 plus 8 is 40 plus 4, that's 44. Do you follow? So one way to convert into one's complement is using the maximum value. We know that after 83, the next value is 128. Diba? So, mabilis. So, we use 127. 127 minus 83. 44 is the one's complement. If you convert that to binary, that's the same value. Another way to convert 83 into one's complement is this. 83 in binary is 1010011, right? You don't have to, you just say 64 plus 16 gives you 80. 80 plus 2 is 82. 80 plus 1, 83. Okay? You can flip the zeros and ones. So this becomes a 0. This becomes a 1, 0, 1, 1, 0, 0. So that's also 44. Take note, no? 44 din siya. Okay? Any questions so far? Convert the number 83 to 2's complement. Okay? 2's complement. So instead of deducting 83, and we know that we get the one's complement, and we know that the one's complement of 82 is 44, we convert 45. Because 44 plus 1 is 45, right? So 45 is 32 plus 8. Ito lang naman ang diferensya nila, 1. So basically, this is the 2's complement of 83. Because 83 is, the 2's complement is the 1's complement plus 1. Okay? Convert 83 to binary. That's another way. Okay? So this is 83 to binary. Flipping zeros and ones. And then we add 1. if you convert this is still 45. Okay, it's already there, no? Subtract number 53 from 97 using 2's complement form. So I have this already. No, you look at this. So 53 is the no. This is the 1's complement of 53 is this, and the 2's complement is of 53 is this. Okay, and then we add. We just add 97 plus 53. So take note the last carry is a 1. The result is positive. Okay, do you follow? Okay, here's the example. No, since the last carry is a 1, it's positive. We just compute right away. Do you follow? We just compute right away. Now here's the example. Subtract 97 from 53. Do you follow? So we know 53 to be this. Okay, and then 97 to be this, right? 64 plus 32 plus 1. That's 97. And the 2's complement, we add 1. So we just add 53 and 97. We add them together. Doesn't matter which comes first. This is the result. The last carry. Okay, the last carry is a 0, so the number is negative. Okay, since the number is negative, we can just assign a negative most significant bit. Take note that the number is 64. Do you follow? Do you follow? Anyway, this is part of the exercise, no? I'm just discussing this so that you can use the solution, no? But you will have to solve your exercise on your own. Any questions so far? No? So we have a very little time remaining. I'm going to upload the simple, no? I'm going to upload the simple exercise on binary subtraction. Example, no? Simple example, the simple example, no? File. Hindi sample, no? Okay. So I'm going to upload this file. This is in your, ano. So you do the exercise, no? And then we will solve it next meeting. Next meeting is a Tuesday, and then we'll have one more meeting. By Friday, you will have your second formative test. Any questions so far? So this weekend is crucial for you. This is time for you to prepare for your second formative assessment. Binary arithmetic, no? Okay. So nobody did. I'm sorry, no, and nobody did the first. A few people did the first exercise, but the second exercise, nobody did it yet. Okay. Okay. Now for the second exercise, no, you pass your solution. Okay, you pass your solution in Excel. Okay, here as an assignment. Okay. Okay. Any questions so far? Okay. Any questions? No? So you do the practice test. We will discuss the practice test next meeting. Okay. Ito no? Practice test on binary subtraction. This one, no? This is the practice test. Okay. So any questions so far? We still have 10 minutes, but we know we don't have any more topics unless you have questions, no? No? So which finishes formally this chapter, no? The chapter on binary numeric representation and binary arithmetic. Okay, number systems and binary arithmetic. Our next topic will be Boolean algebra and logic gates and computer hardware. No, okay, they follow. We will discuss computer hardware here, different structures. No? Okay, after which we will have simple web page development and a little programming on JavaScript. Okay, ito no. Any questions so far? You are doing programming also, no? I presume you have done looping and repetition already. So we'll just review them again when we reach that part maybe in a few weeks, no? Kasi hindi naman, this will not take a long time, no? Computer hardware and Boolean logic, maybe three weeks. Okay. 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 Any questions? So that ends our session today. We are about 7 minutes early, but we have no additional topics, so we will end early today. Okay. If you have questions, you can ask them next meeting. We still have 2 meetings before our second formative test. You will be given about 3 days to do your, more than 3 days. It starts on a Friday and ends on a Monday. Okay. Any questions? Thank you very much, no? Everyone, you study the solutions. It's there in Dagler.
Thank you, sir.
Okay. Thanks for coming. I'll upload.
Thank you, sir.
You. Okay.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Bye, everyone.